Hello everyone, welcome to my channel Physics. So let's do the detailed analysis of second law of motion. So see here, what is second law of motion? I'll just tell in the I'll just give the rough idea about the second law of motion. See, it is the rate of change of momentum is directly proportional to the external unbalanced force, and if you just go into the detail of it, you will get that force is equal to mass times the acceleration. So see here, it is given the acceleration of a particle as measured from an inertial frame is given by vector sum of all the forces acting on the particle divided by its mass, right? So it is a bar which is equal to f bar by m. That is what the second law statement is, right? So or else we can write f bar is equal to m into a bar. The inertial frame is already defined by the first law of motion. Yes, we have defined that, and if you want what is first law of motion and detailed analysis of it, just go into the description, click on the link, you will get the first law of motion. A force F bar acting on a particle of mass m produces an acceleration F bar by m. Right now, in it with respect to the inertial frame. Okay, this is a law of nature. If the force ceases to act at some instant, the acceleration becomes zero at the same instant, right? At the same instant. In equation, a bar and f bar are measured at the same instant of time. So here, the main thing that you need to remember is, see, if we have a block and if you just apply the force of 10 Newton, and this 10 Newton force you applied supposed to be for time t is equal to 10 seconds. Now after 10 seconds at 10.000000001, if I ask at 10.0000001, if I ask what is the force acting on this block, you have to say the force acting on the block is 0 newtons. That indicates what? At the instant you remove the force acting on that body automatically will become 0 right now. And that is the reason if you throw the ball upward, whatever force you applied will instantaneously will become 0, and the force which is acting on the ball will only be the acceleration due to gravity force, or else we can say the gravity force. So I hope this is clear. Now working with Newton's first and second law. Newton's laws refer to a particle and relate the forces acting on the particle with its acceleration and its mass. Okay, so forces acting on the particle, like relation between the forces, acceleration and mass we have. Before attempting to write an equation from Newton's law, we should very clearly understand which particle we are considering. Like system we have, right? System. Okay. In any practical situation, we deal with extended bodies which are a collection of large number of particles. Okay. So like extended bodies, as in you can consider ball, you can consider any random stone supposed to be. It is the collection of large number of what we can say particles, right? Okay. The laws as stated above may be used even if the object under consideration is an extended body, provided each part of this body has the same acceleration in the magnitude and direction. A systematic algorithm for writing equation from Newton's laws is as follows. So 4 steps are there that you need to remember. Okay. So first step is decide the system. So first step is to decide the system on which the laws of motion are to be applied, right? The system may be a single particle, a block, a combination of 2 blocks, one kept over the other, 2 blocks connected by string, a piece of string, etc. The only restriction is that all parts of the system should have identical acceleration. This is the condition that you need to adhere, right? So over here, if you consider block on block, that is A, B, you can consider this as a system. No problem with that. If you consider only one block, no problem with that. if you wanted to consider this as a system, no problem with that, provided the acceleration of C, acceleration of A, acceleration of B must be what? Same. Must be what? Same. Then and only then you can consider what is called as the system under consideration, right? Okay. Consider the situation shown in figure. The block B does not slip over A. The disc D slides over the string and all parts of the string are tight. A and B move together. A and B move together. C is not in contact with A or B, but as the length of the string between A and C does not change, the distance moved by C in any time interval is same as that of by B, isn't it? By A, we can say. So whatever distance moved by this C is the same distance moved by this A and B we have. The same is true for Z also, okay, and E also and D also. Okay, so the distance moved by Z in any time interval is same as that of A, B or C. The direction of motion is also the same for A, B, C and G. They have identical accelerations. We can take any of these blocks as a system or any combination of blocks from these as a system. Some of the examples are, you can consider A as a system, B as a system, A plus B as a system, B plus C as a system, A plus B plus C as a system, C plus G as a system, right now, and any combination, etc. The distance covered by E, is also the same as the distance covered by Z, but their directions are different. E moves in a vertical line, whereas G in the horizontal line. E plus G should not be taken as a system. At least at this stage, we are unable to apply Newton's law, treating E plus G as a single particle. As the disk D slides over the string, the distance covered by D is not equal to that by E in the same time interval. We should not treat D plus E as a system. Think carefully. Okay. Now see over here. Now why we can't consider system as C and E or else E and G? So see, it is because if you consider this as a single particle, now tell me, E is moving in the downward direction, correct now? E is moving in the downward direction, so E will have the acceleration in the downward direction and G will have the acceleration in the forward direction, right? So this is the acceleration of G and this is the acceleration of E. Direction wise these two are not equal. Magnitude wise though they are equal, but the direction wise these two are not at all equal. Okay, now, so not at all equal. These two directions are not at all equal. So if these two directions are not at all equal, then we can't consider E and G as a system. Now why we can't consider the D and E as a system? See, this disc is sliding over this rope, right? This disc D is sliding over this disc, so we can't consider D and E also one system. Why? Because D is sliding, E is fixed. So distance moved by D is not equal to the distance moved by E in this case. Now, so as disc is sliding over the rope, the distance moved by D is not equal to distance moved by E. Therefore, we can't consider D plus E as a system. So this is very important. Why we can't consider D plus E as a system? Why we can't consider D and G as a system, or else E and G as a system? So I hope this is clear, right? So whenever the direction is different, whenever the distance moved by one disk is one object is greater or lesser or different than the other object, then you can't consider the system. But yes, if as long as acceleration is same, as long as distance traveled by the objects are same, so you can consider the system. So A, yes, you can consider the system, no problem. A plus B, you can consider the system. A plus B plus C, you can consider the system. Right now. But if I say, can you consider the system as C and E? C and E. Now here you can't consider C and E as a system. Why? Because C is moving in this direction and E is moving in the downward direction. So C and E as a system you can't consider. But C plus E, yes, you can consider. A plus C plus E, yes, you can consider. So this is how you have to carefully identify the system. Now the step 2, identify the forces which are acting on the body. Once the system is decided, make a list of forces acting on the system due to all the objects other than the system. So due to all the objects other than the system, any force applied by the system should not be included in the list of forces. Indicates what? See, if I consider this is block A, this is block B, this is block A, this is block B, and I wanted to consider this as a system. I wanted to consider this as a system. So on this system, if you consider, and let us suppose there is external force F is there. So if you consider this as a system, in this the tension now is the internal force. So you don't have to consider this tension now. It is only this force F you have to consider in the horizontal direction, and in the vertical direction we have what is called as the N and mg, N and mag. So these two forces and F you have to consider, but this tension you don't have to consider because that is the force applied by the system. So once the system is decided, make a list of forces acting on the system due to all the objects other than system, right? So you considered A and B as a system. So ground is other than object, isn't it? And any force applied by the system should not be included in the list of forces. Okay. Consider the situation shown in figure. The boy stands on the floor balancing a heavy load on his head. The load presses the boy. The boy pushes the load upward. The boy presses the floor downward. The floor pushes the boy upward. The earth attracts the load downward. The load attracts the earth upward. The boy attracts the earth upward. And the earth attracts the boy downward. There are many forces operating in this system. Which of these forces should we include in the list of forces? We cannot answer this question, not because we do not know, but because we have not yet specified the system, which is the body under consideration. Do not try to identify forces before you have decided the system. Yeah, so this is very important point. So firstly, you have to decide the system. System means what? You can consider this load as a system, this boy as a system, or else this load and boy as a system. That is totally your choice, right? Suppose we concentrate on the state of motion of a boy. We should then concentrate on the forces acting on the boy. The forces are listed in the upper half of table. Instead, if we take the load as a system and discuss the equilibrium of the load, okay. So these are the forces. System, if you consider boy, force exerted by earth, external we have, floor external we have, load external we have. Understood? So earth, that is W, that is in the downward direction, and gravitational we have. So if you consider boy as a system, so due to earth, that means we have its own weight, W. Okay, and that is in the downward direction, and due to gravitation we have. gravitational pull. Okay, now due to floor, one more force is there, and that is the normal reaction due to floor, you can write. Okay, that is in the upward direction, and this is the electromagnetic force. Right now, 4 fundamental forces are there. Right, so electromagnetic, gravitational, strong nuclear, weak nuclear. Okay, so it is in the upward direction. So normal force, upward, electromagnetic. Okay, load, we have load. So due to load, we have one more normal force on the head. I'm drawing it over here, and that is N1 supposed to be in the downward direction, and it is also due to electromagnetic force. Right now, so this is electromagnetic, this is also electromagnetic force. So these are the forces which are acting on this boy, right, on this system, we can say, right. External you have to apply, right, external only you have to apply. External due to earth we have, external due to load we have, external due to floor we have. If you consider the boy as a system, now next, if you consider load as a system, then on this load, it is due to earth, we have W, that is the gravitational, we can say, and it is due to boy, we have normal reaction. Now every action has equal and opposite reaction, we can say, right, that is N1, we have upward electromagnetic. So if that is the case over here, this W is like this W is different than this W, isn't it? So this is the gravitational, this is N1, upward and electromagnetic. So this is very important. One may furnish as much information as one has about the magnitude and direction of forces. The contact forces may have directions other than normal to the contact surface. If the surfaces are rough, we shall discuss more about it under the heading of friction. Okay. Now third one, make free body diagram. So this is what the free body diagram is for boy and for load. Okay, now represent the system by a point in a separate diagram and draw vectors representing the forces acting on the system with this point as the common origin. The forces may lie along a line, may be distributed in a plane, coplanar, or may be distributed in a space, non-coplanar. We shall rarely encounter situation dealing with non-coplanar forces. For coplanar forces, the plane of diagram represents the plane of the forces acting on the system. Indicate the magnitude and direction of the forces in this diagram. This is called free body diagram. The free body diagram, for example, discussed above with the boy as a system and the load as a system are shown. Okay. Now this is the free body diagram, as you can see over here. This is the boy as a point object and this is the load as a point object, and you have to draw all the forces over here. Now step 4, choose axis and write equations. So this is the last step we have. Any 3 mutually perpendicular direction may be chosen as XYZ axis. We give below some suggestions for choosing the axis to solve problems. Okay, we'll see that. If the forces are coplanar, only 2 axes, say X and Y, taken in the plane of forces are needed. Choose the X-axis along the direction in which the system is known to have or is likely to have the acceleration. A direction perpendicular to it may be chosen as y-axis. If the system is in equilibrium, any mutually perpendicular directions in the plane of the diagram may be chosen as axis. Write the components of all the forces along the x-axis and equate their sum to the product of mass of the system and its acceleration. This gives you one equation. Write the components of the forces along y-axis and equate the sum to 0. This gives you another equation. If the forces are collinear, this second equation is not needed. If necessary, you can go to step 1, choose another object as a system, repeat steps 2, 3 and 4 to get more equations. These are called equations of motion. Use mathematical technique to get the unknown quantities out of these equations. This completes the algorithm. The magnitude of acceleration of different objects in a given situation are often related through kinematics. this should be properly foreseen and used together with the equations of motion. For example, in figure 5.4, the acceleration of C and E have same magnitude. Equations of motion for C and for E should use the same variable A for acceleration. So now 5.4, I'll just show that. Yeah. So see here. Yeah. Or here, C, if you take acceleration A, E, you have to take acceleration A, though it has direction different. Though it has direction different, you have to consider A as the acceleration. But you can't consider for D A as acceleration. You have to consider A dash as acceleration, as that is free to slide over the rope. Okay. So I hope this is clear. Now see, now I'll just show you how to draw if you consider load and the buoy as a system. Load and the buoy as a system. So if you consider load and the buoy as a system, so you have to consider that both weights, and that too both weights are acting in the downward direction, that is supposed to be W plus W dash, and normal force which is acting from the ground, and that is it. So this is due to earth gravitational force we have, and this is due to ground and the electromagnetic force we have. Only two forces which are acting on this system. Right now, if you consider the buoy and the load as a system, only two forces which are acting on this system, and one is due to Earth's gravitational, other one is due to ground's electromagnetic, right? So if you consider load as a different system, buoy as a different system, then one more force will get added, right? So this is how you have to analyze and try to draw the FBDs. Draw FBDs which I gave in the one of the video. You just go into the description and click on the link, and try to solve 10 questions. Then you will not be having any doubt in this free body diagram. So I recommend you to please go into the description, click on the link, and please do solve that 10 questions. So I'll take one example over here, and it is given a block of mass capital M is pulled on a smooth horizontal table by a string making an angle theta. So this is the block of mass M. This is making an angle theta with the horizontal as shown in the figure. If the acceleration of a block is A, find the force applied by the string and by the table on the block. Okay. So firstly, you have to consider the block as a system. So if you consider block as a system, how many external forces which are acting? Do not consider internal forces, only the external forces which are acting on this capital M. One is due to rope, that is tension supposed to be. Other one is due to earth, that is mg supposed to be, and the other one is due to ground, that is normal supposed to be. So these three forces are acting. So as you can see, pull of the earth mg vertically downward, contact force by the table n vertically upward, pull of the string along the string. The free body diagram for a block as shown in the figure is the acceleration of block is horizontal and towards the right. So this is the acceleration we have. Take this direction as x-axis and vertically upward direction as y-axis. We have then, this is the case. Then components of mg, component of mg along x-axis is 0, n along x-axis is 0, t component along x-axis we have is, so you can make two components for this t. One is along x-axis, other one is along y-axis. So this component is t cos theta, this component is t sin theta. So t cos theta we have, and that is equal to capital M into g. Why? Because we have in the horizontal direction acceleration is there, right? M into a, not g. Why I wrote g over here? It must be a, mass into acceleration. So if you see over here, t cos theta over here is ma. So t you will get ma by cos theta, and n plus t sin theta must be equal to mg. So n plus t, instead of t we can write ma by cos theta. So it is ma tan theta is equal to mg. So the normal reaction we have is mg minus ma tan theta. So that is what the solution says, that normal reaction we have is mg minus ma tan theta. So I hope this is clear now. Now if anyone has any doubt, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.